Welcome in. We are going to walk through Chapter 1 video assignment. So I'll do part of this in Word and part of this in Excel, and then kind of come back for that second question of Exercise 2. But Exercise 1 here is asking you about, variable types, right? And so the first question is explain why blood type is categorical nominal and amount of blood is quantitative continuous, okay? And so the variable types are identified, and sometimes that is the trickiest thing for us because we tend to go way too far into the weeds. And so for this course, please, as you think about things, do not go on a philosophical level and conceptual level. Just think surface, just surface. So more on that when we get to the second variable that we need to think about. Okay, so blood type, why is it categorical nominal? So I'm going to just say blood type is categorical or qualitative, right? You can use either one. Categorical nominal, as it is not a number, right? So blood types are like A, B, and O, and then you get the rhesus factor in there too. But so it's not a number, so that makes it categorical, and there is no natural order to them, right? So you don't, like I listed it as A, B, B, and O. I mean, that's just maybe alphabetical for me, but that order isn't necessarily like it doesn't necessarily need to be the case all the time, right? You could list it in any order that you want, right? Versus like the alphabet A, B, C, D, right? Well, there's kind of a natural order into it. It's sort of been established through culture over time, right? So that's why it's not ordinal, okay? So really, sometimes in identifying these, if you can say it's this because it's not this, and this, right? That works as an explanation too. Okay. Now the second one, amount of blood in a human's body, right? So first of all, amount of blood in a human's body is quantitative or numeric, whatever you prefer. Quantitative continuous because it is a number, right? When it is a number. So when we report it, right, there's a value that we can do math on, right? So math makes sense with the values we get. And then the continuous piece, now this might be a little philosophically like, well, when you put it on a sheet of paper or whatever, it's always like the decimal ends. And I'm like, well, okay, yes, okay. But it only exists to that point because of the measurement systems we use, right? The idea of a continuous variable is that it is anything that lies on an interval between, let's say, a minimum and a maximum number, because it is a number. And so like the minimum that you can have in the body is 0. That would be like you are completely depleted of blood, and then the other case would be like you're full of blood, which that maximum can vary for people, but generally if we're measuring liters, I think it's less than 6 liters. I could be wrong on that, but there is a maximum generally that's accepted, right? And so that's sort of the approach that I'm going to say here, is that it is a number that is between a minimum 0 and a maximum. And I'm not going to list the maximum because that could be, I would need to do a little bit more research on that. But so because it can be anything within that region, that's why it's a continuous variable. Okay. Discrete would be more like you can, there would be gaps between possible values. So there could be like 4 or 5 liters of blood. Well, I think you can get like 4.5, and really anything in between 4 and 5, right? So that's why I'm not going to use the quantitative quantitative discrete option here. Okay. Generally, we reserve discrete for if we're counting individual things and they're more like whole numbers. Okay. Oops. There we go. So, again, don't get super philosophical. Don't go super deep. Just think surface when identifying variable types. Okay. And the second exercise, we need to make a histogram. Histograms are fun. So I'm just going to copy this data. And as I go through and put this into Excel, so I do have an Excel sheet open, rather than pasting it in a row, I'm actually going to show you something that could be useful from time to time, maybe particularly in your work with Achieve. Okay, and so if we paste the data, actually I want to do here, oh, it didn't give me that option. Well, okay. So option A, you can type it in. If you want to copy and paste it, you sure can. But what I actually want to do is I want to copy that once I have it pasted, and then I'm going to paste it as a column, which there's an option here under paste. There's all these different clipboards, right? And if you hover over them, they tell you kind of what they do. And one option is to do transpose. And that just switches it from a row to a column. And that could be, you know, maybe useful for getting it all on one screen, for instance, like I have. Otherwise, you can just type it. Okay. And now we have to go through that process of making a histogram. So highlight all the data so you can click and drag. Another useful trick is on your computer, if you have the first kind of cell highlighted, if you on a PC hold Control, hold Shift, and press down to select the whole data set. Okay. On a Mac, it would be Command, hold Command, and then Shift, and then the down arrow. Okay. And then you can go to Insert, and then histogram you can find in recommended charts. Otherwise, it's actually kind of second row, second column, and right there. Okay, so this chart works beautifully. If you want to change it on a PC, you can just double click the horizontal axis and then, you know, go bin width, change it to like, I don't know, 2 for instance. That's another perfectly acceptable chart. So pick whatever chart type you want to, or whichever, you know, view of the chart works best for you, and then pretty it up. Okay, so add a chart title. So we're going to say this is histogram of, and I blinks in 1 minute. Okay, and then I love labeled axes, so make sure on a PC, if you just have the chart selected, there should be a plus in the upper right corner where you can, you know, add chart elements. For everyone else that's working on a Mac, you might need to select the chart, and then this chart design section of the ribbon should appear, and then you can do add chart element, and then axis titles, right? And then you'd have to do both of these. Okay. But then horizontal axis is going to be your variable that you're looking at. So this is I blinks in 1 minute. And then vertical axis is frequency. Okay. And there we have it. We have our histogram. And then there were some follow-up questions in here. So, you know, once this sketch described the overall pattern, so then that is where we use that sensitive language, right? So talking about symmetry or skewness and that sort of thing. So let's take a look at this. So the adjectives that I would use here, well, it's definitely not symmetric. I would not use that, right? It doesn't look like it mirrors itself. So this is going to have a skew to it. And then we have to figure out, is it skew right or is it skew left? I always have a hard time. So if it is skew right, it's going to have a longer tail to the right. So it's going to be kind of stretched out to the right with less frequent values, which seems to be the case here. So I would use skew right. Skew left would be the opposite. So on the left side of the graph, there's fewer, more extreme values, and it's kind of stretched to the left. And so here that does not apply. So I would say it's skew to the right. And then we can talk about center and spread. So if we can imagine where this balance is, maybe the center is maybe about 4, right? So I'd say maybe it looks like there's a center at 4 with a range from 1 to 11. And I think those are the main descriptors that I would use for this one. Okay, so I think with that we have answered the questions that we need to. So we made a histogram, we sketched it, and described the overall pattern. So we have done that, and we're done with this video assignment. All right,